Let's talk about oil analysis for transmissions. So transmissions are gear drives. They're essentially power converters. It is a very complex component that is usually associated with mobile equipment. It is complex because it has, in addition to the traditional gear sets, you also have brake and clutch band friction discs, you have torque converters, you've also got valves that are all on this device. And it is widely used, as I said, for mobile applications. They are broadly broken out into both highway and off-highway type of applications. And it is one of the largest uses of gear sets in the world because they're in mobile systems. And as a result of that, transmission fluid, which is used to lubricate transmissions, is one of the largest volumes of fluid in the market. For example, in the US, where consumption in 2016 was almost 160 million gallons of fluid, most of that factory fill, or almost 7% of the entire lubricant market. So you can see there's a lot of equipment involved. What makes transmissions interesting is not just that they're a regular gear set, but because they're designed in a little bit different way for the actual mobile applications as opposed to industrial gear drives. So with all these complex components present in there, what has to happen is a fluid is generally developed which is designed to lubricate, cool, and clean the actual transmission components. And this fluid has to be very flexible and has to be utilized to be able to lubricate possibly differentials, final drives, and hydraulic systems. So as a result of trying to lubricate, cool, and clean all of these components, the type of fluid that's developed is quite unique. It's not an engine oil per se, it's not a hydraulic fluid. It has a low viscosity, it's got a lot of anti-friction modifiers in there, it's got antioxidants for long life, it's got additives to improve and reduce potential varnish issues. And as a result of that, each manufacturer of the gear transmission or the transmission sets, or what we know as OEM suppliers, they provide their own fluid specification for transmission systems. And so very common names that you might be familiar with in the marketplace are brand names that are developed based off of the fluid specification for each specific OEM provider, such as General Motors has their infamous Dexron spec, which has been around since almost 70 years. Ford has their Mercon spec. Allison has their TES specification. Caterpillar has their TDTO or FDOA, final drive and axle specification. So a variety of these are used, and it is one of the specific markets where you must match the fluid specification to the actual model performance in order to have optimum operation. And again, just for those of you, why is it a complex set? Well, if you can imagine a gear set, it's a series of gear systems where you have an engine here, which is at a constant speed, and you have a drive shaft at a different speed. And what you're trying to do is modulate the speed according to the particular driving conditions. So if you have a gear set with a series of gear systems, what you're doing is engaging and disengaging at different parts during the drive cycle the gears to be able to mix and match according to to allow the engine to have the most efficient power transmission out to the drive shaft. And so with that, you have a series of systems in there. Most of the gear sets that are present in these things are made out of tool steels for long life. And then you have a series of clutch bands or torque converters, which are actually made out of, in the case of wet clutches, a series of paper-based clutches, so paper materials, or in other applications where you have a dry clutch, you also have ceramic inlines as well. So these are all components and considerations that we think about when we talk about fluid analysis. So why do we monitor transmission fluids? Well, as we mentioned earlier, a lot of these fluids are factory fill, and there's an extended drain interval. Typically, highway applications, you're talking between 50 and 100,000 miles or kilometers before a fluid change. For off-highway, it can be based on duty cycle. But why we worry about fluid in a transmission, or why we should monitor it, is because there can be a series of things that occur that can interrupt the condition and the operation of the transmission. You can get excessive wear due to the duty cycle. The vehicle is being driven too hard, the conditions are too tough. You get excessive wear on the clutch bands and on the gear sets that can cause that metal fuzz that you know about showing up on the system, and of course it can lead to gear slippage. You can have chemistry issues where the fluid has not been changed and it'll start to break down due to heat and excessive use over time. It creates acids, which again cause corrosion, which can affect the condition of the system as well as the flowability of the fluid. And you also have contamination issues. So in a transmission, you can often have it at the lower section of the vehicle. So if it's not well sealed, or you start to have seal integrity issues, you can get water getting into the system. That is the most aggressive ingression contaminant. You can also have sand and dirt getting into the system that can lead to excessive wear as well. And you also can have coolant leaks, especially if you have a heavy duty transmission where it is being cooled using an intercooler with the coolant from the engine. And if there's any leaks there, that's going to get into the system. So as a result of that, we want to be watching for all of these when we monitor fluid. So what should we do for the most recommended tests? Well, we should always be running viscosity. It's the most important physical property of the product. It is critical towards film strength as well as proper gear and anti-friction reduction. We always want to be looking for those large wear debris particles, particularly ferrous. So ferrous density is really a strongly recommended test. If you suspect fuzz showing up on the bottom where you those fine iron filings, you're certainly going to see an increase in ferrous density. Water content, always find out what's going there. Usually 2500 ppm or below is considered to be normal. Anything above that can be abnormal. Oxidation to indicate the level of degradation that's present. We recommend it just being run on a regular basis. We also recommend that glycol should be done because glycol can give you an indication if you have an intercooler leak present. Elemental metals will tell you any other wear metals. It'll also indicate any potential wear metals or additives that may be present in the fluid. And it can also give you indicative concerns when you have a non-metallic wear situation occurring, such as on those clutch bands or wet clutches where you might get some material showing up. Equally, particle count is an exceptional tool for this. Remember, we're looking at transfer and we have a filter. So we need a lot of good fluid flow. We can have a clogged filter. And then oftentimes the particle count is the only indicator when you have a non-metallic failure occurring in some of those clutch bands or torque converters failing. The only indication you're going to have a problem is when the particle count goes up. Metals may not indicate a problem. TAN is an optional recommendation. Some manufacturers recommend it, some don't. Wear debris analysis is also an option if your initial tests are indicating that you have a serious problem. So what solutions do we recommend for on-site analysis? We strongly recommend the Microlab 40 system because what it does is it checks all these tests that are in place here, particularly the Microlab 42 because it includes the ferrous density additional to this tool. So you've got all these tests there, everything that's recommended can be done on one check. The viscosity of the fluid is relatively consistent, is generally in a low viscosity range, so it works well for that product because it's able to pump it through and you get your recommendations immediately.